Good day everyone, I'm your Mr. ATL and welcome back to my channel. So today's video, we're going to discuss about the basic trigonometric identities. So the first one, we have the reciprocal identities. We have cosecant x equals to 1 over sine x, secant x equals to 1 over cosine x, cotangent x equals to 1 over tangent x. On the other side, we have the quotient identities. We have the tangent x equals to sine x over cosine x, and the cotangent x equals to cosine x over sine x. So using these trigonometric identities, we can derive the Pythagorean identities. And how is that? So let us have the equation of the unit circle x squared plus y squared equals to 1. The radius, the measure of the radius there is only 1. Okay? So if you're going to substitute that your x is cosine square x and your y is sine square x equals 1, and then dividing this both sides by cosine square x. Okay, divide this both sides by cosine square x, or multiply both sides by 1 over cosine square x. That's the same. So dividing this, you will have cosine square x over cosine square x is 1. Sine square x over cosine square x. Sine x over cosine x is the same as tangent x. And since it is being raised to 2, that will be tangent square x equals to, this is by the use of the quotient identities here, okay? And 1 over cosine can be found there, and that is equivalent to secant x. Since there is an exponent of 2, that will be secant square x. That will be secant square x. And that is one of the Pythagorean identities. 1 plus tangent square x equals to secant square x. So another thing, from x squared plus y squared equals 1, and that will become cosine square x plus sine square x equals 1. We can divide this also by sine square x. Okay? So what will happen when we divide it by sine square x? So that will become cosine over sine is the cotangent square x. Sine square over sine square x is 1 equals to 1 over sine square x is the cosecant square x. Another Pythagorean identities. Okay? And of course, the other one is the cosine square x plus sine square x equals 1. So this is the first, the second, and the third Pythagorean identities. We can also derive it from here. It will become the cosine square x equal to 1 minus sine square x, and so on. You can do the same thing to the other Pythagorean identities. Okay? So again, let us summarize all of these identities. So we have the reciprocal identities. Number 1, this is the first one. Number 2, the secant x equals 1 over cosine. Number 3, cotangent x equals 1 over tangent x. Quotient identities. Number 4, tangent x equals to the sine x over cosine x. Number 5, cotangent x equals to the cosine x over sine x. Number 6, we have 1 plus tangent square x equals to the secant square x. Number 7, we have cotangent square x plus 1 equals to cosecant square x. Number 8, we have the cosine square x plus sine square x equals 1. You have to remember all of this for you to be able to simplify some trigonometric expressions. Okay? So, we will be adding another 3 identities. Okay? So we have the even odd identities. Again, the even odd identities. So what are these? Okay, so these are the even odd identities. So these are the odd identities. Okay, so these are the even identities. So the proof of these even odd identities can be analyzed through the unit circle. Okay, so let us have an example. We need to simplify the expression tangent x sine x plus cosine x. So the first thing that we are going to do is to write the tangent function in terms of the sine and cosine function. So from our quotient identity, we have tangent x equals to sine x over cosine x. So replacing it to the value of the tangent function, that will become sine x over cosine x. This is sine x multiplied by sine x plus cosine x. Okay, so simplifying this will become this is over 1. So multiply sine x times sine x will be sine square x over cosine x plus cosine x. So we are going to write this fraction as a single quotient by finding the common denominator of cosine x. So this is over 1. So the LCD is the cosine x. Dividing this by the cosine x is 1. 1 times sine square x is sine square x plus cosine x divided by 1 is cosine x. Then cosine x times another cosine x, that will be cosine square x. Okay, so using the Pythagorean identities, you can see that cosine square x plus sine square x equals 1, and that is also sine square x plus cosine square x equals 1. So this term will become 1 over the cosine x. And using the reciprocal identities, you can see that secant x equals to 1 over cosine x, and that is also 1 over secant x is equal to cosine x. Okay, so 1 over cosine x is the same as secant x. So this is now the simplest form of this expression. Okay, I'll give more examples. Okay, another example, we will simplify 1 minus sine square x over 1 minus cosine x. Okay, so remember that sine square x is the same as 1 minus cosine square x. Then copy 1 minus cosine x. And how did sine square x become 1 minus cosine square x? It is because from the Pythagorean identity of cosine square x plus sine square x equals 1, then solving for the sine square x, that will become sine square x equal to 1 minus cosine square x, and that is why we have the value for sine square x, which is 1 minus cosine square x. So this is over 1, and we need to rewrite this as a single fraction with a common denominator of 1 minus cosine x. So let us do that. So 1 minus cosine x divided by 1 is 1 minus cosine x, times 1 is still 1 minus cosine x. Then copy that minus sign. Then 1 minus cosine x divided by 1 minus cosine x, that is 1, times 1 minus cosine square x is 1 minus cosine square x. And then let us simplify by removing the symbol. So just bring down 1 minus cosine x. Negative times positive 1 is negative 1. Negative times negative cosine square x is positive cosine square x. all over the 1 minus cosine x. Okay, now you can see that there are similar terms. 1 minus 1, that is 0. The remaining terms, we have negative cosine x plus cosine square x all over 1 minus cosine x. So at this point in time, you can see that there are common factors, which is the common factor is cosine x, or we can use the negative cosine x. So negative cosine x, to make it negative cosine x, we need 1. Since negative cosine x times 1 is still negative cosine x. So to get positive cosine square x, we need to multiply negative cosine x by the negative cosine x. So let's check. Negative cosine x times 1 is negative cosine x. Negative cosine x times negative cosine x, that is positive cosine square x, all over the denominator 1 minus cosine x. And the purpose of that is to cancel this. Since 1 minus cosine x divided by 1 minus cosine x is 1, we can have that the answer is the negative cosine x. Okay, so let's have the next example. Okay, another example, number 3, we have tangent x minus cotangent x all over tangent x plus cotangent x plus 2 cosine square x. So the first step is to write this tangent x and cotangent x in terms of the sine and cosine function. So using the quotient identities, we have tangent function is equivalent to sine x over cosine x, and the cotangent is cosine x over sine x. So we will do the same thing on the denominator, which is sine x over cosine x plus cosine x over sine x plus the 2 cosine square of x. So after doing that, we can combine this numerator by getting the LCD of cosine x sine x. So the LCD of this, we have cosine x sine x. So this will be the common denominator. So cosine x sine x divided by cosine x. Okay, if you divide this cosine x sine x to cosine x, this will be cancelled. This cosine. Okay, so this will be cancelled, the cosine x and the other cosine x there. So the remaining term, we have sine x times sine x, that will be sine square x, minus cosine x sine x divided by sine x. This will be cancelled. Then the remaining terms, we have the cosine x times cosine x, that will be cosine square x, all over. We will do the same thing here, but this time the operation is addition. So again, that is cosine x sine x, and then sine square x plus cosine square x. So the operation in the numerator is subtraction, that's why we have minus here, and the operation in the denominator is addition, that's why we have an addition sign here, plus the 2 cosine square of x. So this time, as you can see, the denominators are the same. So if we will divide it, this will be cancelled, this one. And using the Pythagorean identity, sine square x plus cosine square x is equivalent to 1. Okay, so it will become sine square x minus cosine square x over 1, or we may omit that, plus 2 cosine square x. So using the Pythagorean identity, to find the value of the sine square x, we need to solve for that, and that will become 1 minus cosine square x. We will substitute the value for sine square x as 1 minus cosine square x. So substituting it, this will become 1 minus cosine square x, then bring down minus cosine square x, then plus, this is square, plus 2 cosine square x. So combining these two, there is an imaginary one here and also in here. So negative 1 minus 1 is negative 2 cosine square x plus 2 cosine square x. So combining these terms, this will give us 0 and the remaining term will be 1. And this is now the answer. Question number 4. We have sine x minus cosine x times sine x plus cosine x. So we may multiply this by using the FOIL method. So sine x times sine x will be sine square x. So outer term to outer term, sine x times positive cosine x is positive sine x cosine x. Also, multiplying the inner terms, we will have negative sine x cosine x. That is also the same with cosine x sine x. Then last term to the last term, the product of that is the negative cosine square of x. So sine x cosine x, let us combine it to the negative sine x cosine x. That will become 0. Then the remaining terms, we have sine square x minus cosine square x. And then the value of sine x is 1 minus cosine square x. Then copy negative cosine square x. That will become 1 minus 2 cosine square x. So this could be the answer. But from here, if you are going to transform this in terms of sine function, this will become sine square x minus the value of cosine square x is 1 minus sine square x. So we will have sine square x minus 1, negative times negative sine square x is positive sine square x. And combining these terms, that will be 2 sine square x, then copy that negative 1. Okay, so this one is equivalent to this one. Okay, so let's have the last example. We have cotangent square x over cosecant x minus cosecant x. So we can transform them by the use of the sine and cosine function. Okay, so we have the cotangent square x. Using the quotient identity, we will get the cosine square x over sine square x. So let us replace it. Cosine square x over sine square x all over. Our cosecant is the same with 1 over sine x by the use of the reciprocal identity. So 1 over sine x. So again, the cosecant is 1 over sine x. Okay, next, we will get the reciprocal of this to simplify since it's the division of the two fractions. So we will have the cosine square x over sine square x multiplied by the reciprocal of that, that is sine x over 1 minus 1 over sine x. So after doing that, this is a square. Okay, so be careful of that. So we have here 1 sine x and there are 2 sine x here. So we will have cosine square x over sine x minus 1 over sine x. So again, what happened to that? There are 2 sine x. We can cancel this. This will become 1 and this will become sine x. So cosine square x times 1 is cosine square x and sine x times 1 is sine x. Then bring down 1 minus sine x. Okay, so after that, since the denominators are the same, we can combine them as over sine x. And and then copy the numerator. We have cosine square x minus 1. So by the use of Pythagorean identity from cosine square x plus sine square x equals 1, so we are trying to find the value of cosine square minus 1. But in here, we will have 1 minus cosine square x, and that is the value of sine square x. But look at this, we are referring to cosine square x minus 1. So with that, multiplying this both sides by negative 1, so that will become negative sine square x equal to, multiply this also by negative 1, so negative 1 times 1 is negative 1. Negative 1 times negative cosine x is positive cosine square x. And arranging these terms will become cosine square x minus 1. Okay, so the value of the cosine square x minus 1 is the negative sine square of x. So let us substitute it in here. So this is negative sine square x over sine x. Simplifying this, it will give us negative sine x. Okay, so this is the answer. Okay, so that's all for today. I hope you enjoy learning about the basic trigonometric identities and how to simplify them. So before I end up my video, I would like to give my special thanks to Mr. Eldren Dalican, and I hope you learned something. Goodbye!